Should've known better to see what I could see. My black shroud holding down my feelings.
Hi, I'm Juha and I'm a hockey player here at USC. I will be going through some physics concepts and examples with you this semester. And remember, just like on the ice, there's no such thing as luck in physics. Just keep your head up and work hard. In this example, we have yet another collision, but we have some offset angles involved as well, which means that we have to solve this problem using components. We could do it in vector form as well, but it's probably more clearer to divide it into components. So what we have here are two skaters. Daniel in D, sitting still, tying skate laces, when Rebecca hits him at 13 meters per second. And Rebecca bounces off into an angle of 53 degrees from her original direction at the velocity of 8 meters per second. And we would like to know what is the velocity of Daniel after the collision, VD2. So magnitude and also the angle of the velocity. First, let's make some notation. So the 30 meters per second, that's velocity of Rebecca before the impact, and 8 meters per second, that's velocity of Rebecca after the collision, subindex 2. And Rebecca's velocity has two components. So this one's going to be VR2 times cosine alpha. Let's call this beta. And this is VR2 times sine beta. So beta is the 53-degree angle. And then in x direction, conservation of momentum is as follows. Before the collision, we only have Rebecca's velocity or momentum to the right, mr times, that's going to be VR1. And after the collision, Rebecca has momentum mr times VR2 and cosine beta. And then we have something from Daniel as well. So let's call the horizontal component V Daniel 2x. And of course he has a vertical component that's going to be VD 2y. So from Daniel, the mass of Daniel times the velocity component that we are solving for. We'll bring this term to the left-hand side where we have mr as a common term, so VR1 minus V Rebecca 2 times cosine beta, and m Daniel VD 2x, and from there velocity of Daniel in the x component or in x direction is mr divided by md, and then the velocity term. And let's put some numbers. So we have mass of Daniel is in fact 65 kg, and mass of Rebecca is 45 kilograms. So 45 kg over 65. Velocity of Rebecca in the beginning, 13 meters per second, minus the velocity of Rebecca after, 8 meters per second, times the angle of her velocity, 53 degrees. And with these numbers we get 5.67 meters per second in the x direction for Daniel. Now, same thing in y direction. Initially, we have no momentum in y direction because Rebecca is going horizontally, or in just in the x direction. So we have 0 to begin with, and we must have 0 to end with. So in end we have that of Rebecca, it's in the positive x direction, so let's make it clear. So our coordinate axis is like this, x and y. So mass of Rebecca times her velocity, VR2, times sine v, the y direction, and then we have whatever is David's momentum. We don't know the direction, so we just add it. So mass of Daniel, and he is velocity in y direction. And solving for that, it's going to be minus mr over md times VR2 sine beta. And Daniel's mass is 65. Oh, that's Rebecca's mass, of course. And Daniel 65. Then VR2, that's 8 meters per second, and sine 53 degrees. And we get minus 4.42 meters per second. So that is negative, so it's downwards, like we already indicated here. And that makes sense because when Rebecca bounces in the positive y direction to conserve momentum, Daniel must bounce the negative direction. And then we can calculate the magnitude of Daniel's velocity by using Pythagorean theorem. So the x component squared plus the y component squared gives us the magnitude. That's 7.22 meters per second, so about 7.2, like this. And then we can evaluate what is the angle alpha. So tangent alpha is the y component divided by the x component. So y component is minus, or we're looking only at the magnitude, so that's 4.42 divided by the x component, 5.67 meters per second. And alpha is the inverse of that, 4.42 divided by 5.67, and that gives us 37.9 degrees, or approximately 38 degrees. That's the angle alpha there.